Okay, hello and welcome to the presentation, Teaching Design Challenges, getting ready for Model Solar Vehicle Challenge in your classroom. This video is basically aimed at teachers, and it's to help teachers understand the nuances of teaching design challenges, such as the Model Solar Vehicle Challenge. What we're first going to do is we're going to talk about what most people think a design challenge is, but actually isn't. A design challenge is not something that's linear, and a lot of people think that it is. They think that we start off with an idea, we draw up the idea or we design it, we then build it, we then race it, and we come first. It's actually not that linear. I think the reason why people believe it is linear is two reasons. One, a lot of people actually are inherently linear in the way they think. They like the world to be linear. And also a lot of education is laid out in a linear manner. And so we're just accustomed to sort of having a beginning, a middle, and an end. And that's based on some feedback I've had from some other teachers who have gone through this process of getting involved in the Model Solar Vehicle Challenge when they've realized it's not the linear process that they once thought it was. It is actually more like this, and this is an explanation for design put forward by a guy called Nigel Cross, who's a researcher in design cognition and including engineering design. And this is the system that I taught when I was lecturing engineering design at university. We start off with our overall problem. We then break it down into a subproblem or a number of subproblems. And that's relatively linear and fairly easy. But then as we try to find solutions to the subproblems, we realize we have to go backward and forward, because as we try to solve the solutions, we get a better understanding of what the problem actually is. And this is something that's called coevolution, which is very much a hallmark of design challenges. It's where by solving the problem, you better understand it. And it's not a linear thing, like I've said before, which you might be familiar with. Let's say you've given the students a maths problem, and you expect them to put the numbers in, do the arithmetic, and come up with the answer at the end. It's not like that. Sometimes in the process of solving the problem, you understand what it actually is. And sometimes you'll hear people talk about what the real problem is. Once you've come up with your sub-solutions, you put them together into your overall solution and you compare that to the overall problem as you believe it has been stated or what it actually is. You'll then sometimes realize that it's actually not, and you have to go backwards and forwards again as you bring these sub-solutions together into an overall solution. And you might find that you now have a new understanding of what the overall problem is, which you then once again break up into sub-problems. You try to solve backwards and forwards, bring it together into the overall solution. Once again, a bit of backwards and forwards as you understand what the overall problem is compared to the overall solution. So you'll see we're steadily moving counterclockwise here, but we've got some backwards and forwards here. You might take 2 steps forward, 1 step back, maybe another step back, 3 steps back, 5 steps forward. You'll be backwards and forwards a number of times, but you'll basically be moving forward on the whole. In contrast to this, where we've only got 1, 2, 3, 4, and we just keep on moving in the same direction. What we need to realize now is that we are actually doing some backwards and forwards in here, not like what we probably initially assumed. And it's also okay to do that. You will find some students will find this very confronting because up until now, they've always understood what they had to do, they did it, and it was done. It's not like that now. They'll try to do it, it won't work, they'll have to come back and try again. So now that you've had this understanding of what problems are actually like, what should you actually do? I would strongly recommend a flipped classroom, which is how I taught design. We've got more classroom activities, students can go away, work on things, come back, share ideas, share insights, and they'll then get more of an idea of what's actually going on, particularly if you can give them some information beforehand, and then they can come in and try working out something together. You'll find that that'll be a lot more beneficial than if you just sort of lecture them and then expect them to go and do it by themselves. I would also strongly recommend that you just get something built early on just to play around with it. So for example, this design here, even though it's not going to meet regulations, could be a way of just understanding how you're going to connect the solar panel to the motor. Just what happens when you do that. You'll have a better understanding. You've tested your sub-solution, and in this case you'll probably find it's not as good as you were hoping, and you now have to think, well, what does this mean for the overall problem? Also expect that your students are going to be going through a cycle as they learn. Maybe remind them of that as well. I would also suggest you start as early as you can and continually consult the regulations. The regulations essentially define your overall problem. So by being able to start early, break the problem down into subproblems and actually test things pretty quickly to get a better understanding, you can then go back, compare it to your regulations, refine your understanding of the overall problem, and then maybe break it down into subproblems differently from what you have in the past. So let's just quickly summarize. This is not what a design challenge is like. It is not linear. It's very important that you understand that you need to get that idea maybe not only out of your own mind, but also of your students as well. It is something that is more iterative. It does steadily move forward, but more in a circular manner as opposed to a linear manner. But there are some backwards and forward stages there, and that should be expected. It's what we call coevolution. To be able to get the most out of that, I would suggest a flipped classroom where you get your students to basically read up on what they need to do, get some understanding, and then have a go at trying to solve it. And that could be something, for example, just building some basic test models to see how things actually work, and they'll then be going through this cycle here of improving their understanding. Definitely start early and always consult your regulations because they define your overall problem. Thank you for watching. Remember, we are here to help. If you want to contact us about anything, www.modelsolar.org.au, and I look forward to seeing you at our next challenge, and I also look forward to helping you make it to that next challenge. Take care.